on to section 3.2 about percents, part 1. The first three examples follow the same questions that you'll see listed up here. And the first thing we need to talk about is translation. These are translating English words into math symbols, just like we talked about previously. So I'm going to give you a couple of translation keys. When you see the word is, replace that with an equal sign. The word of in English translates into the math symbol of multiplication. And percent, of course, stays percent. In our case, what or what number, or the case where we don't know what we're looking for, we replace this with a variable. And for our case, just to keep consistent and not to have to think which of the letters I want to use, we're just going to keep using X. So our first question states, 22 is what percent of 620? So we take this English sentence and we translate it into the math symbol sentence. So I'm going to take it straight for what I read. So I'm seeing 22 first, so I write 22 is, I translate that to math, which is a symbol of equals. What? I don't know what is, so I'm going to put in a variable, and we're just going to use X. What percent, that stays the same. Of means multiply, and 620 stays 620. There we go, we have our sentence now. 22 equals X percent times 620. So now we just need to find the X percent. And in solving these equations, we need to do the opposite and backwards of the order of operations. So right here, I want to isolate the X, and I have a multiplication sign. So to get rid of that, I need to divide both sides, because I need to do the opposite. Divide both sides by 620. So I'm going to divide this by 620, which cancels out. So I'm going to go ahead and cancel it out. And I also need to do this to the left-hand side to keep it balanced. And then I'm going to come over here to my calculator and do 620, 21st, 22 divided by 620 gives me 0.035. And I need to change that to a percent. So I'm going to type in, or I'm going to write, well, let's put 0.035. Now to change that to a percent, we move the decimal over 2 places to the right. So I get 3.5% equals X percent. There we go. So the answer is 3.5%. All right, let's try the next one. Again, we translate it, and these, the ones that we're looking at now, are an exact translation. It even lines it out just like the math sentence would. In some of the other examples, when you hear more than or less than, that's when it is kind of reversed. So that's how you translate those ones. But these ones are straight through. So I look at what is 26% of 725. So I translate every single one of those, what being X. And in this case, I don't have a percent attached like I do on 1, so it's just X. Is means equals in math. 26%, I could go ahead and write 26%, or I can translate or convert that back into a decimal by moving it the decimal over 2 places, which gives me 0.26. Of means times 725. There we go. Pretty nice. So now we just need the calculator to give us 0.26 times 725 gives me X equals 188.5. Now there's a way we can check this. On every single one of these, all we have to do is put back in what we get for X into the original and see if it really works. So let's go ahead and check on this one. What is 26% of 725? So we'll put 188.5 over here. Does that indeed equal 0.26 times 725? Yeah, that's what we just got on the calculator over here. Let's try the next one. 37 is 25% of what? So I'm going to translate it directly. 37 is means equals. 25% is the same as 0.25, but if you want to write 25% and then convert it later, that's up to you. Of means times, and what? We don't know, so we put in the variable x. Okay, to solve for this one, I need to isolate the x, so I need to get rid of this 0.25. So I need to do the opposite, which is divide by 0.25 on both sides of the equation. These ones will cancel, and instead of doing the strike through feature because they're separated, I'm just going to delete that and type that into, oh, maybe we should, I'm going to put this back in so that you can have that in your notes. Let's just copy and paste this down next line so that we don't skip steps. Okay, so those will cancel, get rid of that. And that way it all lines up for when we want to check it. So I'm okay with that. So we'll come over here and do 37 divided by 0.25 gives me 148. So here, 148 equals x. There we go. And again, we can check this by plugging 148 in for x up here. And I'm going to take this off because this was our original sentence. And we'll put 148 here times 0.25. So 148 times 0.25 equals 37. Yep, equals 37, so we did it right. So we always have a way that we can go back and check our answers on these ones. Okay, let's move to the next part. This is when we are dealing with tax and also discounts. So our first example gives us the original price, $68.92, and a tax of 7%. And we want to find the final price. So it's just like walking up to a cash register and the price tag says $68.92. We know that in this particular state and county that it's 7%, and we want to know what's going to happen when it goes through the cash register. So we translate this one again very similar to the first three examples because the tax is 7% of the price tag. Of meaning multiply. So I'm going to change my 7% to a decimal. 7% of times the original price, $68.92. Now this will give me how much money I need to, or I'm being charged on tax. So I'm going to put that here. This is what we need to pay for sales tax. So we're going to do $68.92 times 0.07 gives us $4.82 because we're rounding to the nearest penny for tax. But that doesn't tell us our final price. That just tells me how much I have to pay for sales tax. So I need to find the total by adding the two together. $68.92 plus the $4.82, and that will give me my final price. So I'm going to come over here and add $68.92 to give us the final answer of $73.74. There we go. And it's in dollars. And it looks like I changed my problem at some point in figuring out what I wanted to do. So this was wrong on the answer side, but it's 73.74. There we go. Okay, let's try the next one when we have a discount or a sale. So the original price is $19.99 with a discount or a sale of 40%. So how do we figure that out? Well, we know that it's 40% of the price tag. So again, just like before, instead of it being tax, this will be the discount, how much money we take off. So it's 40%, so change that to a decimal by moving the decimal place over two places is 0.4 of meaning times the sale or the retail price, or $19.99. So we're going to come over here, $19.99 times 0.4, and I'm just using my number pad over here on the side. You can type it in on this with your arrow or the mouse, or if you would like to go ahead and use Excel, that works as well. So that was $7.99, so we round that up to $8. We can do that in here as well. On Excel, to make it calculate like a calculator, put equals 0.4 times 19.99 gives me, rounding that to the nearest penny, the 6 rounds up the 9 to a 0 or a 10, which rounds this up to a 10 and rounds that up to an 8. So it's $8 that we will subtract for the sale price. So now I need to take the original and take off what I get for my discount or the sale, which is $8. $19.99 minus $8 gives me $11.99. So that's my final price when I go to the checkout, $11.99, and I'm going to highlight that as my answer. There we go. Okay, now that we kind of understand the process, we're going to be doing it all in kind of like one step, or writing it out as an equation. So remember up here, we multiplied either the tax or the discount by the original price, and then we add or subtract it to the original price or from the original price. So let's come down here. That's important because these next ones, I don't have the original price. So I need to work it out kind of like an equation. So what we did, and I'm going to come down here. Okay, so I don't know the original price, but I do know to find the amount that I have to be paying for tax or the sales tax, I need to times the percent or the tax percent to the original price. But I don't know the original price. What do? A variable. So we do x, and I need to times that by the 6.5%. But again, we need to change that to a decimal. So 0.065, and I can put times x or I can leave it because without anything there we know that it's a multiplication. So I'm just going to leave that. But that only gave me how much money I have to pay in tax, and I have the final price. So I need the tax and I need to add that to the original price, which was x. Okay, so let's double check. Let's come back up here and just make sure that we did it right. We did the tax or the sales tax percent times it by the original price, which we did here. We just don't know what the original price is. And then we added that to the original price to get the final price. Perfect. So this should equal the final price of $52.31. I think in your book they might have these two reversed as x plus 0.65x. It's the same thing because when you add, you can add one way or the other and you'll still get the same thing. Okay, so now I want to solve for x. In this left-hand side, I have 0.065x plus x. I can go ahead and combine those. The coefficient here in front of the x, there isn't a number, so we automatically know or assume that it's a 1 because 1 times anything is whatever the other thing is. So I can put the 1 there and I can go ahead and add. 1 plus 0.065 gives me 1.065 and times that by x, which equals my 52.31. But I still have an isolated x, so I need to do the opposite, which is divide both sides by the 1.065 on both sides so that it cancels on the left side and I'm only left with, or isolated, the x. So I'm going to come up here and say I canceled these out now, and x equals, so fast, x equals 52.31 divided by, let's go ahead and find that out, 1.065. I can use Excel just like we did before. 5231 divided by 1.065, or we could come in here to the calculator, clear that out, and get 5231 divided by 1.065. There we go. Either way, it gave me the answer of 49 point, and then we round to the nearest penny, so that's 12 cents. $49.12. And that was the original price. And we can always go back and check that by following the same procedure we did in number 4, multiplying this by the percent, so times by 0.065, and then we add it to the original price, which was $49.12, which gave me $52.31. That's perfect. So I can always go back on these ones. So if you're unsure on the test, go back and check what you did. And if you get the same final price, then you did it right. Okay, let's try the next one. It's a little bit different because on the discount, we subtracted. And I subtracted the discount from the original price. So it's a little different than this one. This one I added the tax to this, and so that was a little backwards, I think, than what your book does. So this one, we're going to need to do a little backwards too because we need to subtract the discount from the original. So let's come down here and just work it out. So I need to work out what I did on the first one, which was find the discount. It was 30% off of the original price. Of meaning times. So I need that original, I don't know what that original price is. It doesn't say. So I'm going to do X. And I need to times that by the discount, which we know is 30%. Changing that to a decimal is 0.3. Okay, so that gave me the discount. And what did I do with that? I subtracted the discount from the original. So I need to take the original and subtract this. What was the original price? We don't know, so we have to put an X there. Okay, now that I have the original, subtracting 30% of the original price, that'll give me my final price, or what I need to go pay at the checkout stand, which is $85.17. Okay, so now I need to just work through the equation like we did before. Again, there's nothing in front of the X, so I can put a 1. And now I have 1x minus 0.3x. 1 minus 0.3. If you're not okay with that, go ahead and use your calculator. It's like saying 10 minus 3, but you have a decimal place in there, so we have 0.7. 0.7x equals the 85.17, and I need to get rid of that 0.7. So I need to divide both sides, divide by 0.7, divide by 0.7, and over on this side it will cancel. I'm going to go ahead and copy this so that just like before we can show all of the steps. But now these have canceled out and I get x equals 85.17 divided by 0.7. So let's come over here, $85.17 divided by 0.7 gives me 121. It's bigger. Should that be bigger on this one? Yeah, because this was a discount. I need the original price to be a larger number because I was discounted the 30% to get my final price. So this is x equals the original price of $121 and round that to the nearest penny, so 67 cents. And again, we can always go back and check this. So our sale price or discount was 30%. So 30% of the original. So I'm just going to press times and find the 30% off. So it should have taken off $36.50. Let's check it. $121.67. Subtract the $36.50, and I have two ways I can do that on the calculator or graphing calculator. I can do $36.50 by just typing it out, or I can press second answer, which is kind of nice because then I don't have to worry about uh, rewriting everything and it's exactly perfect. I don't have to worry about typos or rounding errors. And we'll get $85 and uh-oh, it says 16. But remember, we round, so it's $85.17. That's perfect because that was our final price. And I can do that on Excel again, and it would also take care of any rounding errors by just cell referencing each thing instead of rounding and typing it out myself. So we had $85.17 and we divided that, divide that by 0.7 to get our original price. And if we wanted to check that, we would take this and say equals 0.3 or the discount price times, now cell reference this so we don't have to worry about any typos or rounding errors. Gives us our $35.50. Now in this one I can press equals the original price, which we already have, subtract the discount, $85.17. Perfect. So we have two different ways we could go about that. Those of you who want to use your calculator, some of you will like Excel, whatever, whichever you prefer. Okay, let's move on to the next one. Story problems. I think a lot of you might kind of clam up and get a little nervous as soon as you see the word story problem or as soon as you see that it's not just an equation for you to work out, it's saying something. Don't worry. Whoops. We'll take it one step at a time, and remember, we're just translating straight from English into math symbols and math sentences. So our first one says, if the population of a town grew 40% up to 16,700 people, what was the population of the town last year? That sounds like what we did up here in these problems. Something jumped up in price here, but this one, it just jumped up in population. So, what happened? Well, I know that it grew 40%. So, let's just go ahead and change that to 0.4. This 0.4, it grew 40%. So, it was 40% more than the previous year. Well, I don't know the previous year. So, I'm going to times that because I said more or 40% of, so times what it was last year, or X. So that will give me my growth. But that only gave me how much it grew. It didn't give me the full and total amount. So what did we do on the previous examples? If it was 40% of, and that was a growth, I just need to add that to the original again to find the final, which is 16,700. Very, very similar to this one, except it was dealing with money and taxes, and this one's dealing with people, but the process is the same way. Okay, so now it's just a matter of working it out. So I can add those two together like I did before. Again, there's that 1 here. So adding these x's, I get 1.4x equals 16,700. And then I need to get rid of the 1.4. Just copy and paste that down the next line to show my work. I need to get rid of that, so I need to divide both sides by 1.4 to isolate the x. Oops. Copy that down again. This is going to cancel out, and then I have 1.4 here. All right, so now it's just a matter of plugging it into my calculator or Excel. Since I have Excel right here, let's just go ahead, make it calculate like a calculator by putting in an equal sign, 16,700 divided by 1.4. There we go. So my final amount, or my original amount, so x equals, from the previous year, 11,920. Let's go ahead and round this up because we're dealing with people. So 929 people. So there we go. And that matches my answer that I got before. That's mostly for my benefit and if you wanted to kind of scroll through so you didn't have to watch so much of the video. All right, and if I wanted to check this again, all I would do is take this, times it by the 40% because that's how much it grew, equals zero point 0.4 times my original amount, and then add those two together. So equals, let's go ahead and do the sum formula just because we're going to change it up a little bit. And there we go. There's our final population for the next year. Let's try the next one. If the price of an object dropped 15% to $43.25, what was the original price? Exactly like the previous ones with the discount. So instead of it just listing it out, and if you're more comfortable listing it out like this, take that information that you got and write it out. So we have original price, we have discount, and we have final price. If this makes you more comfortable, then just work out what you gleaned from the problem. If the price of an object dropped 15%, so the discount was 15%, to $43.25, $43.25. There we go. We're looking for the original price. So I'm going to put a question mark. And since we don't know that, we can put an X. So you can write it out like that, or you can break it down like we did previously, either on 7 or on 5. It's totally up to you, whatever you feel more comfortable with. Because I'm looking for the original price, it's going to more closely mirror number 7. So we took the discount and we subtracted it from the original price, which we didn't know, so we used X. So here, same thing. I have the original price and I'm going to be subtracting the discount, which is 15% of the original price. 15% is 0.15 of meaning times the original price we don't know, so we put an X, and that will tell me my final price of $43.25. Okay, so now again, I can go ahead and combine my X's. Because there's nothing in front of this X, I just put a 1. So I do 1 minus 0.15. If you're not comfortable doing that in your head or you're worried about making a calculation error, go ahead and use Excel. 1 minus 0.15. I'd rather you be more accurate and worried about the process of what's going on in 9 than the calculations of 1 minus 0.15. I'd rather you get that accurate than trying to do it in your head. There we go. So we get 0.85x equals 43.25. Okay, so now I need to continue solving for x. So I'm going to divide both sides by 0.85. Since I only have one more line, I'm going to divide it up here, 0.85, divide by 0.85. So the next line is going to be very similar. And I'm only going to copy this part because that 0.85 is going to cancel out on this side over here. And there we go. X equals 43.25 divided by 0.85. So I'm going to type in 43.25. Oops, I need to put an equal sign. 43.25 divided by, I'm going to go ahead and cell reference this 0.85 so I don't have to type it in. There we go. So come up here since I ran out of room. X equals 50 point, and round that to the nearest penny. So 2 doesn't change anything on the 8. So it's just $50.88. And I can go ahead and figure out if this is right by checking it. So it would be $50.88, and we can go ahead and use our calculator as well if you would prefer. Clear that out. So $50.88 times that by the discount, which was 0.15. So I should be subtracting $7.63 from the 50.88. So 50.88, and you'll notice I'm using rounded numbers. Beware of doing this because sometimes it'll mess up the pennies. In this case, we're pretty good. $43.25. So it worked. It gave us our final price. Let's try the next one. If the price of a meal after a 15% tip was $34.25, what was the price of the meal before the tip was added? So very similar to the tax problem, we're going to be adding this on. So let's go ahead and instead of writing it all out like we did in this one, let's move to the next step of just writing out what we know. 15% was added or was taken of something and then added to the original price. But we don't know what the price was. So it's just going to be X, the original price of the meal, plus 15% of that original price equals $34.25. There we go. So now let's try the next step. Again, there's nothing before the X, so when we add those, that becomes 1.15X equals $34.25. And to continue solving for the X, to isolate it, I need to divide both sides by 1.15. So I'm going to just copy this and paste it down here and divide both sides by 1.15. There we go. And on the left-hand side, 1.15 divided by 1.15 cancels, or it becomes 1, whichever way you want to think about that. And then we just need to do 34.25 divided by 1.15. 34.25 divided by 1.15 gives us our original price of $29.78, rounding that to the nearest penny. And again, we can go back and check that by putting in that $29.79 in for X, or we can just break it down and times this by 0.15, 0.15. So $4.46 was the tip, or the 15%. Add that to the original, which was $29.78. $34.25. Yep, rounding that up gives me the final price. So the original price was $29.78, and I'm going to label that and highlight it as my answer. There we go. Let's try the next one. I know this looks a little scary, and some of you are going to kind of blink out for a minute. There isn't one like this on your homework, but I thought it would be kind of a nice introduction into 108 because they'll start talking about stocks and shares and investment. So it's the exact same thing as what we did before. So if you don't want to watch this part, go ahead and stop the video right now. It's okay. If the price of a stock dropped 29% per share down to $12.50, what was the price of the stock per share before the crash? So this one is just like the discount. I'm going to be subtracting the 29% of something. So I have my original price that I don't know, so I'm just going to do X. But I need to subtract what happened to that, which was the 29% drop. 29% of the original, or 0.29 times that, which will give me my final price of $12.50. So I'm going to combine those. Nothing's at the first of the X, so I put a 1. 1 minus 0.29, if you're not comfortable with that, it's fine. Use your calculator. I'd rather you be really sure on all the calculations and just worry about what's happening on your step process over here. So it's 0.71x equals 12.50, and we solve it just like before. Divide both sides by 0.71. Copy that down, divide by 0.71 to show my work. And the next step, that 0.71 is going to cancel over here. 0.71 divided by 0.71 is 1, or you can think about it as canceling. And then I'm just left with 12.15 divided by 0.71. So I'm going to come over here, or 12.5. 12.5 divided by 0.71. There we go. So my final, or my original, I should say. X equals $17.61 because that jumps up. So before this stock had a 29% decline, the original price per share was $17.61. There we go. So it was very similar to the discount as we did up here. Okay, that is 3.2 part 1. If you'd like to join me on part 2, which is solving equations with fractions, I highly recommend it. And good luck on your homework.